The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
Busy.
What a great restaurant that was last night.
It was.
It sure was.
Mm-hmm.
Yeah, so...
What did you eat?
I had the fish stew.
Stew?
Stew.
You sure about that, Roland?
You sure you went to a seafood restaurant?
So that's called in Portuguese, the caldeira.
Caldera.
Juan, you had the shrimp Mozambique?
Yes, it was awesome. That shrimp was good.
Yeah. Shrimp Mozambique is just unbelievable.
Yeah, especially with that white rice.
Yeah, they
Here's
give you
the sauce. Oh, that sauce is awesome.
Yes.
So I used the rice to soak it all in. Yum, 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 yum.
Nice. Yeah, so I had the steak with the pepper on top and the egg, rice, double carbs, right? You got rice, you got potatoes, all that juice, that au jus, whatever you want to call it. In Portuguese,
I call that soup.
Yeah, so it's just amazing. I think the plate could have gone back on the shelf. It was that clean when I was done.
Yeah, at the end of my stew, at the bottom, there was just a layer of like thinly sliced potatoes. It was just unbelievable.
Yeah, it looked amazing.
I saw you guys just looking at my soup all night long.
What's amazing to me is that every episode of this podcast, we start off by talking about food. we have issues.
If people saw us, they'd understand that we eat a lot.
Yeah, so everybody knows us at METUS when they see us. They know that we're from the training department. As far as the instructors, not everybody in the training department looks like us, but yeah, we travel a lot and we
Eat a lot.
Yeah, and that's bad. But welcome to the METUS Tech Show, everybody. We got Juan Cardona here, instructor out of the Ohio Training Center.
Arriba.
Hey,
Here he is.
Roland Wager, instructor out of the Orlando Training Center.
Sunny Shine, Muggy State.
Yay.
And myself, Steve Pimentel, instructor out of the Southborough, or we call it the Boston Training Center. And welcome to Reversing the Pain of Reversing Valves. Why are we reversing the pain, Juan?
Because it's painful. Whenever you go and deal with reversing valve on a heat pump, I mean, think about it. You've got 4 pipes in close proximity of each other.
Yeah.
And it's a nightmare trying to get those pipes unsoldered if you have a replacement.
And there just isn't a lot of room in there for you.
Not at all.
Nope.
Yeah. Yeah, it's we say it's a pain because everybody's intimidated by it.
Yes.
Brazing one in or replacing one, there is a lot to look at as far as brazing one in or unbrazing. As far as unbrazing, you're replacing the valve anyway,
right?
But putting the new one in, now we got to take some care in there that we don't overheat the valve. That's the biggest problem.
You got to control the heat. You got to control that flame. And if you for a first timer and you overheat that valve, guess what? You're doing it over again.
And you're going to have 3 or 4 people in a room that all do it differently.
Yes.
And all right, but they all do it differently.
So what I would like to do is start talking about the components of the reversing valve.
Let's do it.
So on the reversing valve has 4 pipe connections. On one side, there's a single pipe, and that one is your discharge line connection, and it connects to the straight to the discharge line of the compressor. The other side has 3 pipe connections, of which the one in the center is the one that is connected to your common section. Typically, it's connected to one of the pipes going into this accumulator before it goes into the compressor. Okay. So we've got 2 pipes there. The other 2, which are found at each side of the common section, depending on whether the valve is energized or the solenoid valve is energized on heating or cooling. By the way, ours happens, for the most part, to be energized on the heating mode. We've got a handful of models where it is energized in cooling mode, but for the most part, it's on the heating mode. So those two pipes, depending on whether the valve is energized in heating mode or cooling mode, one pipe will be connected to the outdoor coil, and the other one will be connected to the suction going out of the outdoor unit into the indoor unit. And then also we also have the pilot valve where the solenoid coil mounts on. The pilot valve has four pilot tubes connected to it. One connects to the discharge line, providing the high side pressure reference. One is connected to the common suction, providing the low pressure reference. And the other two connects to either end of the valve body, which provides the pressure differential that is necessary for the valve or the slide to shift back and forth. That valve cannot shift without pressure differential.
Yeah, good point. So if that system's flat, we're not moving that valve.
Right, and sometimes it's not always the reversing valve. Sometimes you have a compressor with compromised valves or scroll,
right,
and you've got pressure, but it's equalized pressure. Right. So you got to look for pressure differential at either end of that valve body.
And that can act a little funny too if a system is low on charge as well.
Yes. Yeah, because you got to build up that pressure to force that slide to move over to the other side. So that's mainly the main components of the valve body.
All right. So to recap, so we're taking in the Mitsubishi world, we're talking Mitsubishi heat pumps, either commercial or residential. We're energizing that valve in heating mode, energizing the solenoid valve to energize to shift the pilot valve to either put pressure to one side of the valve or the other. And we're going to send hot gas to either the condenser coil to subcool in cooling.
In the cooling mode.
Yep.
Or we're sending that hot gas directly to the indoor coil, and we're going to heat the space, and we're going to meter that refrigerant through an LEV on the outlet of that evaporator. But keep in mind now that that flow is reversed.
Right.
So know your flow, know your path of refrigerant.
Yeah, in the heat pump mode, that's just a continuation of the discharge line, basically what that is.
Correct.
Superheated vapor going in there.
So your suction becomes your discharge line in the heating mode.
And vice versa. Yep.
And that's why when we refer to the coils, we call it indoor coil or outdoor coil, not evaporator or condenser, because it all depends on the mode of operation.
What's function
One
is,
thing that we need to be aware of also is our coils, our solenoid coils, are energized with 208 or 230 volts AC.
uninterrupted out of the board.
Right. And where the industry energizes it with 24 volts AC.
And I'm glad you brought that up. So that brings an idea to mind where, and this happens quite often. We've had tech support calls for it, where you have a basic M series 1-to-1 unit, and for whatever reason, the electrician ran 115 to that unit, and it's a 208 heat pump system. Maybe there's a problem in the breaker panel, or they just ran 115 to that unit. What's happening is that unit will, with an M series, will actually run in cooling mode.
Right.
And if you install that in the shoulder months and they go to flip that unit to heat, well, guess what? No 208, no reversing valve.
That's right. Yep.
So always check your voltages, incoming voltages, not just a voltage at your solenoid. You want to check your incoming voltage at the condensing unit before going any further.
Yeah, that's one of the things that should always be checked first.
Yeah. On startup as well. I mean, even if it's warm outside, you're not going to energize it for a long period of time. But just check it out. Check out everything, because that does come up. And I've heard audio of people calling in with that problem, where it's like, running at 120 volts, but it was running fine for a period of time, and then all of a sudden went into heat, nothing.
So what are some of the things that can happen? And we're pretty much turning to Juan, because he's our, out of all our instructors, I feel he's our subject matter expert when it comes to reversing valves. And what are the top 3 things that can happen to a reversing valve?
Well, the top 3 is the solenoid coil can fail, and we're going to talk about how to troubleshoot that. the valve or the slide inside the reversing valve can stick. And there's multiple reasons why that can happen.
Or collapse.
Absolutely.
Yeah.
Because the seal on it can collapse in it. And that will prevent pressure differential from happening, so it's not going to slide.
So it basically just leaks on by.
Yes. And that's the third point is valve leaks or it's bypassing hot gas. So talking about the solenoid coil is just a resistance coil. All you got to do is first make sure you've got 208 or 230 going to it, or else it's not going to energize the pilot valve. So once you've confirmed that you've got 208, 230 going to it, and it's still not energizing, or you don't hear the pilot valve click, which is it's a really pronounced sound that you can hear, then what you would do is you can remove the coil off the body, and while it's energized, you can take a screwdriver, like a Phillips screwdriver, and go inside where the pilot valve would go in. You should feel a magnetism. But be careful. Be careful not to hold that coil with your hand. I would hold it with a pair of pliers because the coil, without a load, without it being mounted on the valve, is going to get very hot. And it will burn you. I'm speaking from experience. That happened to me at one time.
It's happened to me as well in a supermarket case where all the solenoids were energized without being on the solenoid valve body.
Yeah, they're going to burn up.
And they melted right through
Yes.
the bottom of the cases. Yeah, it was a big mistake.
And you can take like a little Mitsubishi thermostat screwdriver and just touch the screw, and sometimes you can feel
You
that
can feel it that way.
there.
Yes.
Yeah, as well.
The other way of testing the solenoid is by resistance, and you would have to look it up in the service manual as to what that resistance value will be.
And just to comment on that, once again, mylinkdrive.com, because some solenoid coils have a higher ohm resistance than other because of the size of them, because of the capacity of the system. So not one number fits all as far as ohm readings.
That's right. So that's the solenoid coil testing in case it fails. So now let's talk about why or how does the valve stick. First thing that comes to mind, lubrication. If there's no lubrication inside that valve is not going to shift. So think about poor piping practices.
Oh, yeah.
There's an episode on that. So if there's no lubrication in there, it's going to stick trash or debris by not using nitrogen while bracing. Guess where all that debris is going to end up? It's going to end up in the valve, and it's going to end up in the
little nooks and crannies.
yes,
It's going to find a place
in
to
the whole system.
cause
And the
resistance.
strainers.
Yep. Oh,
the
yeah, absolutely.
strainers will become plugged up. So that's what causes the valve to stick. Also, again, what is the one thing that causes the valve to shift?
Pressure differential.
Bingo.
Yep.
You two are good at this.
We watched your video.
I am impressed.
We watched your video on valve replacement.
So the third thing is the valve leaking through or bypassing. Typically that happens when you overheat the valve because the bellows, which is what sometimes called at each end of that slide, they are Teflon type, Teflon material or plastic. Right. So if you overheat the valve, that Teflon or plastic will melt, and it will allow high pressure vapor to go into the low side. So it gives you a bypass scenario. And then, in some cases, it may not be the valve. Could be the compressor valves or the scroll not building up pressure, not compressing the vapor coming in through the suction. And what happens is that scroll or valve or piston is going to be free spinning, not creating compression. And typically you can check that with an amp probe on the compressor if you're getting lower than normal amp draw because you're not compressing. Compressing is loading up the compressor. So you don't have that, so your amp draw is going to be a lot lower.
And we have in our classrooms, we have rare earth magnets, and the body of a reversing valve is brass. But what happens is the magnets are so strong, they'll actually attach to it because of the steel inside of that. And you can literally watch those magnets slide when that reversing valve gets energized. And then the other thing, too, is when we shut down the system in the heat mode, you normally hear that big whoosh of refrigerant balancing off.
Right.
And as tempted as you are to do this, please don't grab your ball peen hammer out of your truck and try and hit the side of a reversing valve to get it to shift. Now, you, gently maybe tapping one to see if it does shift when you do that. But at the end of the day, if you have to hit a reversing valve to get it to shift, shouldn't you replace it?
That's a good point, because if they stick once, guess what?
They'll
It's going to stick again.
Yep. Yeah.
And that regarding hitting the valve body, I actually had a job where someone had replaced 3 valves in the same unit. So I was called out to do a site visit, and it was pretty obvious. It was a fairly large valve, and the brass casing where the slide is
all dinged up.
Oh yeah, it was pretty obvious. I asked him, "Well, how did you try to get the valve to shift?" He goes, "Well, pressure differential." He had all the answers, but the evidence was telling the truth.
Sounds like
the evidence was that he was hitting that valve too hard.
20-ounce frame and
Yeah,
hammer.
or a 24-inch crescent wrench. We've all been there. So yeah, those are the 3 things that mainly happen. So we got to be careful. We got to treat that valve gently.
Right. Yeah. So now let's talk about replacement procedure. But now this is the pain of reversing valves.
All right, that's pretty good. You're very gifted there, Steve.
I'm trying to use the buttons that came with this
it was a
podcast
button.
machine. So
I thought it was your gift.
I'm trying to get the most money out of this thing.
I took a chance one time, hit a button, and the garage door opened. So I was definitely the wrong one.
Button.
Leave it up to Roland.
All right, so replacement procedure, and here's where the pain is. I mean, who wants to replace a reversing valve?
No one.
Now, I know technicians that have been at it for quite some time, and they'll do the unbracing right at the valve. And I'm fine with that, because then they have had experience in controlling the heat, keeping, and now again, the replacement valve is bad, so it doesn't matter how hot it gets.
Right.
But you got to be able to control the heat when you put the new one on. If
No,
you're
we have
putting-
we have a number of Juan. We have a number of different tools that have come out over the years, different torch tips,
Yes.
to help in this. So it's not as bad as it used to be, but brazing the new one in, that's where we got to
the
be
key.
careful.
You got to keep that valve cool. So what we recommend, what I've done in my years of experience, is I've always looked for joints that are near the valve, but not right at the valve.
Mm-hmm.
And if there's no joints in any of the 4 pipes, what I'll do is I'll cut the pipe. I can always brace it in with a coupling. So I'll cut it out, and that way it's out of the way, and I've got plenty of room all the way around that valve. I can apply heat equally, and then I don't have anything in my way to prevent me from pulling the piping. The trick is you got to have to mark how that pipe goes into the new one.
Yeah.
Because if you don't mark it and which pipe goes where, you may install that valve backwards. I've had experience with that.
No, you're probably better off scratching that copper with an awl or a scratch awl or something. But I just wanted to make a point real quick. I've done a lot of reversing valves in the past, but never had the pleasure of doing one on a Mitsubishi unit. And it's tight quarters.
That's a good thing.
Compared to a unitary product,
You beat me
got
to the punch on that one.
a 3.5 ton split system condensing unit. You can get in there.
You can get inside the unit.
and work on it like an old Chevy or something. Jump right in there and work on the thing. But not with Mitsubishi. It's tight quarters.
Yes.
And we understand, that's where the pains are, right?
Right. And then we always recommend, as an industry, to always use nitrogen while bracing, because every time you heat a pipe, you break down the oxygen inside that pipe, and that oxygen breakdown turns into what? Corrosion.
Yeah.
And all that.
Oxidation, right?
Oxidation,
Flaking,
right.
What you see on the outside of the pipe when you braze, that black flaky oxidation,
it's like
whatever you want to call it,
scaling.
that
It's like
scale,
scaling.
and that's happening inside the pipe as well.
And if you ever taken that and just kind of like it falls on a piece of metal or and you tap it, and it breaks up like talcum powder.
Yes.
And that stuff gets right in the oil, and it just
And it gets in our strainers too.
yeah, it's absolutely.
Even on the LEVs. I've seen them on
Oh, yeah,
LEVs as well.
It's a very small opening.
So yeah, if you want to do it right, you need to use nitrogen while brazing. So now we've taken the old valve out. We're ready to put the new one in. So again, the new valve, you have got to learn to control the flame, hence controlling the heat. You don't overheat the pipe. You may think the hotter the better for the brazing rod to melt. No, you got to remember you're overheating that valve if you're not protecting it. That Teflon seal is going to be compromised. You're going to put the valve in, and guess what? You're going to find out that you've got the same problem over again, and then you're going to have to replace it again. So always get control of that flame. Protect the valve with a wet rag or a paste to keep it cool. And there's
some heat transfer paste, right?
Yeah, a lot of products out there now for heat sinks.
Yes. So after you brace those pipes into the valve outside of the unit, then you can bring and reinstall the new valve into the unit either on the same joints that you unbraced them at or couplings. But now that you're far away from the valve, then you don't have to worry about heat that much. But as Steve mentioned, you're in a very closed quarters, so make sure that wires, thermistors, all that stuff is not in your way of that flame.
Good point. Yeah. So our thermistors are usually held in place by a small holster, and those can be unattached and put to the side
Easily.
Yeah.
Yep. Easily.
So after when the new valve is in, as we always talk about in our training, we pressure test. We pressure test with 600 pounds PSI, and then we bubble check it, and then no leaks, perfect. Then we do a triple evacuation, where we have 3 levels of microns that we look for. We look for, what is the first level? 4,000 microns at first. Yep. Then we break that vacuum with dry nitrogen. We don't pressurize the system. We just break that vacuum. We bring the gauge to 0.
Right.
Then we start our pump again, and we bring it down to 1,500 microns. Then we do the same thing. We break that vacuum with dry nitrogen 1 second time, and then we bring down again the pump on, bringing it down to 500 microns.
Or lower. I mean, sometimes you can get even lower than that.
Absolutely. So once you reach that level, you isolate the system. You should have a micron gauge that sees the system, not the pump. I've seen many pictures, especially on Facebook, of individuals bragging about their installations. And the installation is a beautiful installation. But then I see that micron gauge on that common hose between the the gauges and the pump. And so how are they doing the RICE test? Because the recommendation is once you reach 500 microns, you shut off the gauges and you give it 60 minutes and watch that gauge, that micron gauge, to make sure that it doesn't go up. Now, let's say it does go up to about 1,800 microns and levels out at 1,800. That means that you still have moisture in the system. That means you have to do the triple evacuation over again.
Right. And let's talk about manifolds and gauges for a second. You know, when I graduated vocational school back in 1992, right? Long time ago.
At least it wasn't 1970s.
What year did you graduate?
1992.
Oh my God.
Yeah.
That was a baby.
And I'm still, I'm up there in age.
I had
You guys are older.
I had installed other systems by then.
But anyway, they give you a set of gauges and they tell you this is what you use to pressure test. This is what you use to charge. This is what you use to purge and pull a vacuum with these gauges.
Yes.
And it's true to a point up until you get to pulling a vacuum. Right. When we're doing an evacuation, manifold gauges are probably not the best choice for the tool I'm going to use. I'm going to try and minimize the amount of connections on a vacuum.
Right.
I'm going to try and break it down so all I'm using are just 2 vacuum-rated hoses, very important.
Yep.
2 vacuum-rated hoses with a micron gauge. Now I've just eliminated O-rings and seals and colored hoses that may leak in a vacuum. They're known to leak in a vacuum sometimes because they're reverse porous. right? But with whatever brand gauges you're using, it doesn't matter. Just know what you're using your tools for. Not every tool, is good for that purpose of pulling a vacuum, like the manifold. Bring that down to single hoses, a micron gauge, and some way to isolate that micron gauge, like Juan was just mentioning, not to the vacuum pump side, but to the system side. That's important. And are your microns going to rise when you do a rise test? Of course.
They're going to buy something.
Yeah,
Yeah.
they're going to
Temperature.
rise, but at some point they're going to stop.
Level out.
Right. And when it does, that system is dry. There are no non-condensables in it, and you have no leaks.
Right.
Right. These are some of the things. Having the right tools. I just wanted to mention that having the right tools for the job make your life so much easier.
Absolutely. So now that we've got the new valve in, we pressure tested it, and with 600 pounds, no leaks found. We triple evacuated it down to 500 microns, and we did the rise test for 60 minutes, and everything checked out. Now, hopefully, at time of installation, someone did the additional refrigerant charge calculation and wrote it somewhere inside the unit for future reference.
Yep.
But if no one did that, then guess what? You're going to have to measure line set length,
Yep.
calculate the complete charge, calculate the additional charge, and then weigh the system in. Right?
Absolutely.
You got to know how much refrigerant to put in it. And then after you add that refrigerant charge into the system, you start the system up and you test performance. Just because you turn the switch on and the system comes on, you're not done yet. You need to check for one thing is that reversing valve shifting? So you have to put it in both modes, confirm that it does shift from heat to cool and from cool to heat, and then you check performance. And what is the best tool you ever owned was a thermometer
Absolutely.
to check delta T.
Yep.
And that checks airflow and refrigerant charge. Mm-hmm. So we check delta T at the indoor coil, at the indoor units, and we look for 20 to 30 degrees delta T.
Excellent.
I believe that the video of you doing that training on the reversing valve is on our
It's
website.
a free webinar.
Yeah.
It's on
free
LMS.
Yeah, it's not your typical PowerPoint voice webinar. It's actually a video of Juan demonstrating and showing some close-ups of a reversing valve and going through the whole operation, installation, and covering all of that, diagnosis of a reversing valve. So definitely, this has been an excellent show.
Thanks for being here, Steve.
Yeah, thanks for being here,
Yeah,
Roland and Juan.
come again.
Yeah, absolutely.
All right, guys.
All right.
Have a great day. Be safe out there.
We'll see you at the next episode.
Hasta la vista.
I'll be back.